Hi class, today we're going to be naming and writing ionic formulas. So naming and writing ionic formulas. When naming an ionic compound, the metal is always written first and is the same name as the element, so nothing changes with that. The name of the nonmetal is the first syllable of the nonmetal and then "ide." So in this case, oxygen would be oxide. A space is placed between the name of the metal and the nonmetal. So here I put a plus sign, but it's really not there when you write it out. So we have calcium. Calcium does not change even though it's an ion. And then oxide gets changed, is the result from oxygen, and we drop the YGEN with oxide. The name is calcium oxide. Now keep in mind, this does not show what's actually going on. This is positively charged, this is negatively charged, this has a 2 plus, this has a 2 minus, and then it's reduced down. We are only writing it out. So with ionic formulas, we write it out, but it really does not show you anything more than the name that's going on behind the scenes. Here is some names for some compounds. So we have Ki, this is potassium iodide. We have magnesium bromide, magnesium 2 plus bromide, 1 minus magnesium bromide. And then we have here, may look like it's difficult, but it really is not, because again, this does not have any impact on the name. The name is aluminum oxide. These are things that you're just going to have to know what the charge is when dealing with this. There's nothing in the name to show it. You have to learn it to know if I give you aluminum oxide, you have to give me this chemical formula. Okay, so steps to writing ionic compounds. So if we have a compound K2O, you have to identify which is the cation, which is the anion. Step 2, name the cation by its element name. Step 3, name the anion, first syllable, and then we add "ide" to the ending. Fourth, write the name of the cation first and the name of the anion second. So first one, we're going to take the K, and it is a K plus. It's from group 1. The anion is from group 6. It needs 2 more electrons to fill an octet, so it's going to have a 2 negative charge. Another way you could do is reverse the crisscross. You can look at this as reversing the crisscross, and that'll also help you understand what you're looking at. All right, so we've broken this down to the cation and the anion part. Next one, name it. So potassium as an ion is still just potassium. Nothing changes with that. Then we go to the next one, and it's oxygen, but we are changing it to oxide. We drop the YGEN, and now we put it together. K2O is potassium oxide. Okay, so now we're going to go through, we have 3 of them here, and we're going to break these down the same way. And unfortunately, the way that they gave it, they didn't break it down where we could do these separately, but that's okay. We're going to just look at each one and go through them. So we have Ca and an O. So Ca is, again, you could do it 2 ways. You can reverse crisscross these if you can visually see that. And but with the names, it doesn't really help with these. It's not really showing you, when you say the names on these, it doesn't tell you how many superscripts or subscripts. But as we start working with these more, I won't jump ahead. Let's just stick with this. So we have a Ca and an O. So we know that Ca is calcium, and here it is. We've got it's got a 2 plus charge from group 2, and O is an anion. It's got a O2 negative charge. Aluminum has a plus 3 charge, and an oxygen is a 2 minus charge. I'll tell you right now, as we're learning, the same ones tend to come up over and over and over again. So you get comfortable with those before they're expanded out on some of these. Not all of them. Sorry if you hear my cat. She's going crazy in here. All right, so the next thing. Name the cation by its element name. So we break this apart. We know that Ca is calcium. It's an ion, but we don't do anything with the first name of a ionic compound. Stays the same, whether it's neutral or it's an ion. So this is calcium, this is aluminum, which is under 3, and this is magnesium. So that's the first half. Second one is, excuse me here. Second one is to name the anion and then change the "ide" ending. So with this one, we have oxygen on both of these. So it's not going to change for either one. It's 2 minus and it's oxide and it's oxide. With chlorine, we're not worried about the 2. We're not worried about any of that. We're just looking at this. It's a -1 charge because it's here and it needs 1. So it's going to be chloride. Oxide, oxide, chloride. They all end in "ide." And then, I don't know, I have double slides on here. Yeah, I do. So on here, the first one is named calcium oxide. The next one, see, it did duplicate. I don't know why my slides all of a sudden are acting weird. And then here is aluminum oxide. And the last one is magnesium chloride. So if you break them down into what the cation is, what the anion is, and then it allows you to put the name together. So for one thing, it's nice that you don't have to worry about the subscripts of how many there are, but at the same time, when you need that information, you actually have to know it. You're going to have to learn it. You're going to have to look at a periodic table. You're going to have to do more. So when writing it, it makes it easy, but when you have to reverse it and put it into a chemical compound formula, you're going to have to know it. Okay, now we get into what's harder. This is harder than just dealing with group 1, group 2, and group 3. Now we are dealing with transition metals. Transition metals we have avoided up to this point, and that's everything that's here, because they have different oxidation states. So copper has 1, copper has 2, iron has 2, iron has 3, lead has 2, lead has 4, chromium has 2, 3, 6, I think, and 5. It goes on and on. So a lot of these have a lot of oxidation states, and there's no way set with easy rules to determine what they are. So we have to do a little math for some and some crisscross method for others. It's not fun, but you learn how to do it, and once you learn how to do it, then you can go forward. Now the nice thing is there are 3, I underline this, there are 3 here that only have 1 oxidation state. When they only have 1 oxidation state, we do not put a Roman numeral. So how these have a Roman numerals, that's because they have more than 1 oxidation state. So when we write these ones out, we have no Roman numeral because there's only 1 oxidation state, and that's whatever you see it as here. These are the fun things you're just going to have to know. Okay, so let's get started. First thing I want to point out, we use Roman numerals. There is no space in between. And if you go online, you will see this mistake everywhere. Even though the rule is there is no space between the metal name and the Roman numeral. So don't make the mistakes that other people are doing. Same as when I've given you sig fig rules and calculations, and people don't follow the sig fig rules. There's a lot of information online, but not all of it's right. A lot of it gets halfway and then they get lazy and sloppy with it. So there is no space between these. This is the correct way of writing these out, because that oxidation state that they're showing on here belongs to the metal, not to the non-metal, and not in the middle as a space. It belongs to the metal. Okay, so I found a chart here to show you. I'm not going to give you guys anything crazy, so maybe 5 might be the most. I would not probably, I'll be honest, I'm probably not going to give you anything here. If it is, it's part of the homework, not something that I willingly give. But we'll deal with that as it comes up. You definitely should know at least up to 5 on these. You should be comfortable with knowing some of these. It will make your life easier when you're dealing with this. So here are some metals that have more than 1 positive ion. As you can see, bismuth has a 3, so there's a 3. Bismuth 5. And this is from your book, so I suspect they may give you higher oxidation states, okay? Chromium is some bad stuff. This is... if you have to deal with it. I used to work with it in the lab. You take precautions. Chromium 2, chromium 3, cobalt, and you can go down and see gold has different oxidation states. Copper. One of these represents the blue, one of them represents the green. If we had been lab, you would have seen some of this stuff. Remember, some of the names do not match exactly with how we know them because they're using a different language. So tin is SN, and it comes in tin 2 and tin 5. Mercury looks a little strange, so if I can avoid mercury, I will. Manganese is not magnesium, it's manganese. So these are just, this is a slide to help you understand Roman numerals and how some of these are written out. Okay, this chart is actually in your book or text. It's in your e-text. This is very beneficial to have. It does not have all the oxidation states. If you go online, you can Google ion charges for periodic table, and it'll give you, some will give you all of them. However, I'm very suspicious of anything that I find online, so you should check on something else. If you, try to find a reference. For some reason, like, look at, they left beryllium out on here. I don't know why. But these are the metals. Here's the metalloids and the non-metals. So these are giving you some of the charges. Silver. So you see some have only one oxidation state. So that's how you see them like this on here. Okay, so if you have this chart, this makes life easy. But you should also know the hard way of knowing this stuff. It's nice to have shortcuts, but you don't retain the information. And with chemistry, the problem is that students expect to have problems that match all the time what's given in the book or given here. And that just does not happen. And students, I know I've had students who were like, well, we didn't cover that exactly. No, we didn't, because chemistry isn't like that. Chemistry expects you to know the foundational information, and then it'll move it around on you. So you can't memorize one problem expecting to see that problem over and over again. Chemistry moves things around, as in a math problem, where it expects you now to be able to solve for other variables once you understand the foundational stuff. So you may not like the harder way of doing these things, but you definitely should know how to do it. All right, so determination of a variable charge. I showed you that there's a chart here, but not all of them are listed, and that's on purpose is what I suspect, so that you can do the actual math on some of these. So here we have, some of these have variable charges. That means different oxidation states. Use the charge on the anion and charge balance to calculate charge on the metal ion. I do not know how they made up that title. If I had caught this earlier, I would have fixed it. So here is the compound. It's MnF2. We want to know what the oxidation state is of manganese. Yes, it's on here, or it was on the previous one, but you still have to solve for it. Now, these are not really very different, but this is how the book gives it. I solve it as X, and it makes my life easier. So we have the charge here, which we don't know, and then we have 2 fluorides, and we put a negative charge, and we equal it to 0. So there's not real big difference in these, but I don't like the guessing game that they put up. So they make this a question mark, and then they, figure the math out here. So if this is 0 and this is -2, then this has to be +2, because 2 minus 2 equals 0. So this means that the question mark is 2. I don't like that. I just make it X. Solve for X. So if I solve for X, I have X minus 2. X, bring it on the other side. So remember, if you subtract, if you add on one side, you have to add on the other side in order to make this 0. So that's what I did. X equals +2. So my charge on the Mn is actual 2. Now you could also crisscross it, and that works in some cases, but not in all. So this is also another way to look like, okay, well, the 2's here, so it's got to be an oxidation state of 2. Check the math, because some of these reduce down, and you don't always know just by looking at it. Okay, so naming ionic compounds with variable metal charges. So we're given a compound of FeCl2. So let's name this compound. Now, what we notice here is we have 2 chloride ions with a -1 charge. So we have it here. Negative has a 1 charge. We don't know what the oxidation state of iron is for iron, and it's a transition metal, which has different oxidation states. So here, I left a little thing out here. I always notice my mistakes. I go through them, and then all of a sudden I always see, after I've gone through them 100 times, as I'm recording. So I solve for X. So this stands for my metal. And then I solve for the anion. So I have 2 of them, and they're -1 charge. So that makes them -2. So X minus -2, bring this over as a opposite sign, X equals 2. So this metal is actually iron 2. That is what that's what the charge is on this. So it doesn't go into, this is iron 2 chloride, which I jumped ahead. So the first step it wanted here was the metal. So that's what I did. I broke it down. It's iron 2. So it has a 2 oxidation state of 2. So I can translate that to iron, no space, and 2 in there. Now, chlorine is not chlorine anymore. It's chloride. So we change that to chloride. And this is iron 2, no space, but a space here, iron 2 chloride. So it's not difficult. This is not difficult math, but you have to keep track of what you're doing in order to make sure it's correct, and then you can transfer it over to the name. All right, so let's take a look at this one. This is tin, and we have 2 oxygens with it. So let's figure out the naming of this one. So same thing here. I jumped ahead and I put it here in case you're wondering, but in the next few slides, we're going to solve it the same way. So we have the easiest thing here is you don't have any information to work with on this one. So you have to take everything that you know about oxygen. What do we know about oxygen? Oxygen has a 2- charge. We don't know anything about tin. So we set it up the same way. We have 2 oxygens with a -2. That makes -4. And then we bring it over. So this tin has an oxidation state of 4. The Roman numeral is, if you can remember, is IV. Just put IV that in your head. Stick something that allows you to remember that that's what it is. So 4 is IV. That's how I remember it. Okay, so we're not worried. We want to name this compound. But if it doesn't make sense to you why it looks like this, I put it here. You would reduce it down. Remember, we don't leave anything as a 2 and a 4. This can be reduced down to this. That's why. But this is about naming. But just in case some students were confused about why it looks like that, even though it's tin-4, the name does not change even though we reduced it down. It's tin-4. So the next thing we want is write it out. So we write it out. And then oxygen is now oxide. So this is tin-4 oxide. All right. So here is writing formulas from the name. So we're going to go the opposite way. The formula for an ionic compound is written from the first part of the name that describes the metal ion with the parentheses and Roman numeral, no space. Remember, there's 3 transition metals that don't have it. We're not talking about those right now. We're talking about the ones that have this. The second part of the name specifies the nonmetal, and subscripts are added to the charge. So let's break this down if this doesn't seem like it makes sense to you. All right, but this is the compound, and this is the name that goes with those compounds. All right, so you can do it a couple ways. You can crisscross it. So write the formula for iron 3 chloride. Remember, I told you that this parentheses belongs with the metal. So when you write this out, it would be Fe3+. We know that chloride has a -1 charge, so you write that out, and then you crisscross them. So the 3 goes on the chloride, and the iron there would be a 1 here, and that is the same thing, iron. So if you have to look at a compound, you say it the same way as this. Say iron, jump to this side. This shows you the oxidation state. Iron 3 chloride is the chemical formula. Now, like I said, some of them don't match up. Tin-4 oxide, when you're looking at this, doesn't match. So you would have to actually do some math to make sure that you're dealing with the right one. Because if you say tin-2 oxide, that's not right. I've been doing this enough that I could tell you right offhand that I know this one's not right. Why would I know that? Because oxygen always has a 2 negative. There should always be a 2 negative here. And because there isn't, this tells me that this is a reduced compound. Okay, so let's go on. So if you weren't sure, just do the math and it'll check out. All right, so we have 3 compounds here. Unfortunately, they didn't break these up, so we're going to have to do them all together at once, but that's all right. So we have nickel 2 sulfide, zinc chloride, and iron 3 oxide. So zinc has 1 oxidation state, so that's why there's no Roman numeral. Remember, there's 3 exceptions to this. All right, so let's break it down from what we know. First one, nickel 2 sulfide. This is telling you that this is a nickel with a 2+. The name of it will give you the correct oxidation and so forth. It's when we get into a chemical formula that we reduce it down. But the name will not change. So like tin-4 was still tin-4. When we wrote the chemical formula was the only time it was reduced down. But writing the name of it will show the correct of oxidation state. So this is an Ni2+. We know sulfur is below oxygen. It's a group 6, so it's a 2 negative. Now we break down the cation and anion for zinc chloride. Zinc has a fixed charge. That fixed charge means it has 1 oxidation state. It doesn't have any others. So it's a 2+, and that is a 2+. We have now been dealing with chloride enough to know it's a negative, so it's chloride. And then we have iron 3. This 3 goes with the iron, so it's 3 plus. And we've been dealing with now oxygen enough that hopefully you start knowing that this is a 2 minus. And now crisscross them. So nickel 2 and sulfur, which is sulfide 2 now, has a 2 minus. So this is a 2 and 2. This would not last. We need to reduce this down. So you're going to see it like this. And this is the same as with oxygen. Sulfur is below oxygen, so it always has a 2 negative on it. So if you don't see a 2 on the crisscross, then that means this was reduced down. I look for those little things. I memorized them. I know oxygen is always a 2 minus. So I need to look at the compound. If I don't see it, it's been reduced down. Okay, so zinc chloride. Zinc has a 2 plus. This one has a negative, so we're not going to pay attention. Make sure you bring the 2 down, and it should be zinc chloride. We don't say zinc 2 chloride because it has 1 oxidation state with it. This is things you have to know. And then iron 3 oxide. Looks a little difficult, but it really is not. Iron has a 2 negative. Iron 3, it's telling you right here it's a 3. Crisscross them down, and here is the compound. Now, if you wanted to say this wasn't here, and I gave you this, which we'll practice this, but this is iron 3 oxide. That's how you would say. You crisscross it still when you're looking for the oxidation state. And that's it. Thank you.